Hey, in a recent series of videos, we presented the new features introduced in iOS XR 7.3.1. But with this release, we are also introducing new products, and we'll start today with two new fixed form factor systems. And I'm very glad we have Scott Carter with us to introduce them. Scott is the product manager working in Cisco MIG Group, who supervised this router's development and their launch. Then we'll dive a bit deeper in the internals and the configuration of specific features. You can find the shortcuts in the description below and more details in the iOSXR.io companion article that we'll publish very soon. And so now, I give the stage to Scott.
Thank you, Nick. Hi, I'm Scott, and it's my great pleasure today to introduce you to the latest member of the 5500 product family, the NCS57B1 platform. It's comprised of two chassis, the 6D24 and the 5D-SE. The first thing that you'll notice is that they're the first to carry the NCS5700 moniker. This simply denotes that they're based on third generation Jericho MPUs. The B denotes Jericho 2, and the 1 is the height and rack units. Since its inception in 2016, the NCS5500 product family has found tremendous success in delivering dense 100 gig routing platforms to support the core peering and aggregation use cases. Fixed 100 gig routers like the NCS5502, the NCS55A136HSE, and the NCS55A124H all allowed customers to create economical 100 gig distributed fabrics in roles that were traditionally the domain of large modular systems. Each prior fixed system used multiple Jericho or Jericho Plus ASICs, often stitched together with one or two fabric ASICs to achieve multi-terabit 100 gig. Now we can accomplish the same or greater forwarding capacity with a single MPU, reaching 4.8 terabits per second in the 6D24 and 4.4 terabits per second in the 5D-SE scale system. Both have 24 ports of 100 gig. The 6D24 has 6 ports of 400 gig, while the 5D-SE has only 5. The remaining 400 gig is used to address the enhanced stats and counter capabilities found in the OP2 external TCAM. All ports feature QSFP-DD optics cages for the increased power and thermal requirements necessitated by extended reach ZR and ZR Plus optics modules. Rounding out the faceplates on both systems are the full complement of timing, console, and management ports. A single MPU design paired with the 400 gig interfaces allows us to fit everything in a 1RU form factor that's only 600 millimeters deep. This is helpful in space-constrained environments often found at the edge of mobile aggregation networks. These networks will also appreciate the integration of Class C timing and timestamping found in the 57B1. Additionally, all ports are capable of full line rate MACsec for providers seeking security in outside plant operations, or in large enterprise and public sector operators looking to encrypt and secure their WANs. Now, MACsec support will have to wait until 7.4.1, but you can order both platforms today with 7.3.1, and they're expected to ship out in April. And now Nick can take us deeper into the technical benefits of the NCS57B1 platform. Nick?
Thank you, Scott. Let's start with the positioning. You can use the NCS57B1s in 5G infrastructure, routed optical networks, distributed core and peering fabrics, cloud, leaf and spine architectures, etc. At the end of the day, to rationally answer the position questions, you must take into consideration different parameters, including port density and port types, form factor, and more particularly the depth of the system, supported features, supported scale and performance, power consumption, finally, price and licensing flexibility. And that's probably not an exhaustive list. The system offers 24 ports 100 gig, and half of them can accommodate high power optics like 100 gig ZR. They must use the top row here. Also, on the right, you have 6 or 5 ports 400 gig, and all of them can support long reach, ZR and ZR+. I will describe later the options with breakout cables. So you have 24 times 100 gig and 6 times 400, or even 48 times 100 gig with breakout. Don't forget, you can break out a 400 gig port in 4x100 gig and expect it to connect to 100 gig SR4, LR4, or CWDM4. You will need to connect the breakout ports to one lambda 100 gig on the other side, like QSFP28 FR. Coming back quickly, on the naming and how to decipher it. NCS 55 represented the products based on Qumran MX, Jericho, and Jericho Plus. NCS 57 is a new family containing J2, J2C, and following. The letter B brings more details. It's a J2 NPU. 1 is a number of rack units. 5D or 6D describes the numbers of 400 gig slots. 24 for 24 ports 100 gig, and SE is also 24 ports 100 gig, but with external TCAM this time. Now, for your reference, a chart describing the different product names if you are using the flexible consumption model or the business as usual license. Redundancy? We are considering a fixed router, actually a system on a chip. That means we don't have dual route processors, hence no control plane redundancy. Also, it means no fabric card redundancy either, no fabric card at all. The system offers power supply redundancy, 1+1, we have AC and DC options, and fan trace redundancy, for instance 5+1, it's a front-to-back cooling architecture. The NCS 57B1 is built around the Jericho 2 NPU. It's a 2-core, 16nm ASIC offering 4.8 terabit per second of bandwidth on the interface side and 5.6 terabit on the fabric side. For this specific platform, the fabric SerDes are used only to connect to the external TCAM. Like its predecessors, it's a hybrid architecture with both on-chip buffers, for instance 32 MB, and off-chip HBM, high bandwidth memory, that's 8 GB in ingress only. And it's based on a VOQ-only forwarding decision model. We have an internal MDB that can be carved to specialize a router in specific roles. And on the 5DSC systems, we have an external TCAM that can be used for routes, classifiers, and now statistics. And we are using interface links to connect to that part of the ETCAM. That's why we have 5 ports 400 gig instead of 6. From a block diagram point of view, it's all fairly simple. We have the J2 NPU in the center of this architecture, and we use PHY chipsets in reverse gearbox mode or switching mode to connect to the different ports. This PHY is also handling the MACsec tasks and offers Class C timing, something that is natively not supported on J2. The only difference with the 5DSC is the presence of the external TCAM and one 400 gig port less. We mentioned earlier that only the upper 100 gig ports should be used for high-power, long-reach optics. It's a common thermal restriction that you will find in a lot of products. I invite you to check the TMG matrix to verify the optic types supported in the current release, iOS XR 731. And for the roadmap, please contact your Cisco representative. They will give you the details on future support for optics modules. When you plan the port allocation, there are 2 rules to follow, and they are just applicable for the 100 gig ports on the left, not the 400 gig ones on the right. Rule number 1, you can only configure breakout cable on the upper row. That means ports with an even number, 0, 2, 4, etc. Whether it's a 4x25 gig or a 4x10 gig, you cannot configure it on the bottom row, the ports 1, 3, 5, etc. Also, when you configure this breakout in port number N, it will disable the port N+1. That means the port below can no longer be used. You cannot plug anything in this port N+1, it will not come up. Let me use 2 quick examples to illustrate the first rule. I have a 5DSC here, and a QSFP Plus in port 16 is configured in 4x10 gig breakout mode. Note that the configuration is different from what it used to be on previous NCS 5500 systems. It's no longer done under the controller level, but via a hardware module statement. The port 16 is now showing 10 gig interfaces, and you can see we have 5 tuple here. Consequence, the port N+1, that's the port 17, is no longer available. In this second example, I'm checking the port configuration of a 6D24, and the port number 24 has been broken out in 4x100 gig. That's why you have 4 port 100 gig with 5 tuple here, 0 to 3. Since it's a 400 gig on the right part of the chassis, it doesn't disable any of its neighbors, and port 400.0.0.0.25 is still available. Rule number 2. It can be summarized in just one sentence. In a block of 4 ports, a quad, if you insert a QSFP Plus optic, you can no longer use a 4x25 gig breakout in any of the 3 remaining ports. The block of 4 ports has the following: port 0 to 3, 4 to 7, 8 to 11, etc. as shown in the diagram. If you have a QSFP Plus inserted in port 0, could it be in 40 gig or 4x10 gig mode? Then you cannot configure a 4x25 gig in port 1, 2, or 3. Note that you can use QSFP 28 100 gig, but simply not a breakout of 4x25. If it's not 100% clear, let me use several examples to illustrate this second rule, and we will use the first block, port 0 to 3. In the first example, I have a QSFP Plus 40 gig inserted in 0, and I plug a QSFP 28 optic 100 gig in port 2, no problem. Now if I try to configure the port 2 in breakout mode, 4x25, it will be prevented by the system, because I cannot get QSFP Plus and 4x25 in the same block. Same logic applies if I start with a 4x10 gig inserted in port number 0. Since it's a breakout configuration, it disables the port 1. Then I insert 100 gig QSFP28 in port 2, no problem. Like before, trying to configure 4x25 in port 2 will be prevented by the system. No QSFP Plus and 4x25 in one given quad block. But as long as I'm using 100 gig and not 4x25, I don't have any issue. For example, 400 gig is present in port 0, I configure 4x10 in port 2, that disables port 3, and I insert 100 gig in port 1, all this is supported. Likewise, I can mix and match 40 gig and 100 gig optics in a block with no limitation. Okay, one last example. 2 QSFP 28 100 gig in port 0 and 2, we configured port 0 in 4x25 breakout mode, port 1 get disabled. Now I insert a QSFP Plus in port number 3. No, it does not work. QSFP Plus and 4x25 is not supported. Is it clear? Really, that's just 2 simple rules. Number 1, breakout only on the upper row and it disables the N+1 port. Number 2, no mix of QSFP Plus and 4x25, QSFP28 in a given quad of ports. None of these restrictions are applicable to the 400 gig ports on the right. Let's talk about routing scale now. Since the system is based on Jericho 2, we do have significantly higher routing scalability than Jericho and Jericho Plus generations, at least internally. Let's first take a look at where we store the routes. It's also very different from previous generations, Jericho and Jericho Plus. In a 6D24 system, base, no ETCAM, just LEM and LPM carved out of the modular database. All V4 routes and all V6 routes except /128 will be stored in LPM. V6/28 will go in LEM with MPLS and MAC addresses. Also, LPM will be used to store multicast information. Note that 731 is slightly different than 721, where IPv4/32 used to be stored in LEM. But it's not relevant on this discussion because 731 is the first release supported on NCS 57B1. In the 5D SE variant, we have an external TCAM named Optimus Prime 2. All unicast V4 and V6 routes will go in this external resource. Multicast will still be stored in LPM, MPLS and MAC will still go in LEM, and note that access list entries are now stored in ETCAM, even the flat ones. By flat I mean without using the hybrid access list feature. In terms of scale, we can reach 2.3 million IPv4 routes or 1.7 million IPv6 in the base version, the 6D24. That makes it suitable for a full internet view back again. And for the scale version, 5DSC, we support up to 5 million IPv4 routes or 3 million IPv6 prefixes. That's pretty large, but we can go even further if needed in the future. Okay, let's wrap it up now. The NCS 57B1 routers, 6D24 or 5DSC are offering 400 gig and 100 gig native ports in a very compact form factor. It can be used in many places in your network, 100 gig to 400 gig aggregation, core peering, and pretty much everywhere you think it makes sense. It's powered by a Jericho 2 NPU in a non-blocking architecture. You can use MACsec on all ports, and it's rated for Class C timing. I invite you to check the blog post on xrdocs.io coming with this video and linked in the description below. In the next episode, we'll continue exploring the new products introduced in 7.3.1, and this time we'll talk about chassis and line cards. See you in the next one, and in the meantime, Stay safe.